Hello everybody, your favorite artist electronist, Mr. Q12 here. I'm doing a very simple design and very simple circuit. You can see it here actually, and it's a LM358 opamp operational amplifier tester. It's very simple, very simple. I will show the actual circuit, not this 3D diagram. I don't have the actual circuit, but I have it in my head. It's very simplistic because LM358 is having two gates. Inside, two op-amps, is dual op-amp. This side that I'm having here is for the right side of the chip. So the right side op-amp is this part, and also this part is in parallel with this. So all the functions that I'm using here is for this and for this, but one at a time, not both in the same time. So if I'm having to test this deep chip size, I'm inserting it, do the thing here, check if it's good or not, take it out, and while both are empty, I can put the SMD here version and check if it's good, this specific op-amp from the right side and also from the left side as well. Inside the chip, like I said, it's having two op-amps, and that's it. It's very simplistic, very basic. Pretty much I will show the functionality of it when it will be finished. Right now what I'm having what I'm having here, I'm layouting, I'm playing around with the components, and it is very close as dimensions to what I'm having here. Very close. This is a bit longer, and this is a bit wider. It's more square-ish here, and here is more longer. But you know, it's not perfectly like that, but it's in the ballpark 100%. I'm very happy with yeah, I leave a ton of spaces for this side to actually put positive and negative, some markings. I leave here some extra space on the top to make the title. I also leave it here already, this part here, from here to here. Here it will be the name. Unfortunately, I don't think I will have space there, or if I will move this a little bit here. Yeah, I should have choose longer, but this is the cardboard that I got. Probably I will extend it a little bit with some extra cardboard. I will see. It's not perfectly like in the original design, well, but it will function. I actually scratched my head quite a while. I have for this guy here. This I don't have a normal socket. I forget how it's called. This pin chip holder. I don't have a normal one, and I cut 4 pins from a longer one, and I made I made my own holder for the chips, and I will reinforce it with plastic inside. After I will solder it here on the pads, I will pour some plastic between the two, and I will strengthen it a little bit more, and hopefully it will also glue the melted plastic that I will pour there. It will actually make a little bit of it will link with the existing plastic that is there, hopefully. If not, well, and here with the SMD version, I have quite a lot of these boards, and I completely forget about them, and with a stroke of genius, I remember that I have them. And this LM358 size that I'm having here is fitting absolutely perfectly, and that's all that I need. I only need to place it there and then press it down without soldering it. That's my idea how to use it there. I already glued down this board, so it's not moving anymore. It's quite secure here, but these pieces, I'm only playing with them here. So that's it. It's very minimalistic, and a ton of wires, as you can see, a lot of wires, and they are looking very bad, one on top of the other. But what it will actually be, it will be under the cardboard here. They will be, and I will reinforce with another cardboard, and I will make a very good layer of protection for those wires. And probably a couple of wires here on the top, but minimum. Probably the positive wire and the negative wire, if they are not intersecting. They are intersecting here. Well, I will find another route then, and for not intersecting anything. And but only to suggest that where is positive and where is negative, and the rest of the logic wires that are here, most probably they will be underneath and through holes, you know. And that's it. That's the plan. This is how I'm preparing. I'm taking out everything I can, every component that I have to use. I'm taking it out. I'm preparing it. Of course, the LEDs are not prepared. The resistors are not prepared, but these potentiometers are prepared, are bended into position, and also this device here, this holder, chip holder, is bent to fit here, and that's pretty much it for this stage. I will show more when I will start adding the pads, the metallic pads here, and we'll see from there. Thank you very much for watching, and see you later. Bye bye. All right, I just finished to put all the pads on this board, on this cardboard, and they are looking fine. They're looking right, correct. And like I said, I just finished, and I have to put this back here. These are taken from another boards that I completed. So now I have to put the components, and then after that to drag the wires. And I have this this is my reference setup, and also the wiring is going all over the place here for me to visualize, to see everything. But here it will be another story. It will be underneath here. Nothing of the wiring will be very visible. Yeah, one single detail. Here I was planning, come on, here I was planning to add small little pads here as well for this chip, but being so tiny, uh, so I managed to find this board adapter. This is an adapter to dip sockets, you know, dip 8. These are the pins for the dip, but this is a SOT 8 sockets or pins or dimension for the pads. And if I was making them myself, I'm not completely sure I can make them flat as these are here. They are very extremely flat, and here on this pad. So I choose this pad, but the problem that I'm having right now is this different numbering. So this is for pin 1, this here, and you can actually follow the line here. You can see it is connecting to this pad, which is 1, and 2 is going here, 3 is through a via through here and then connected to that, and 4 is like this to here. And the same goes for this other pins for this other, and this is the 8, as you can see here if you follow it. So I will have to make some holes in the cardboard and then drag the wires from these points to their respective pads here. So it will not be exactly like here. It will be a little bit different, but I will have a good surface here to test my chips, which are very tiny, but the pins are not that good to work with. And this is it about this update. Next I will start mounting the components, and then I will start putting the wires. See you later. And here I have the components, and now let's mount everything I have here. This is the fun part, by the way. Right here. Come on here. And the not so fun part is the wiring, but I will only film the fun part. All right, so I'll have to prepare these pins that I'm having here. Like I said, I made it from 2 elements. So now, these are pins. Get a little solder on down. This is a very important step preparation. Okay, now that it's prepared, now we have to fit it here. Good. Really? We'll put some there. Okay, so this part, this is 2 parts actually. If I'm removing this, this will remain 2 parts, but I will strengthen them with this. I will pour some melted plastic between them and solidify it. Hopefully, that's the idea. Now, let's put this little beautiful. I will have to prepare them as well, not to spend too much time on their pins while I'm mounting them there. I'll spend some time outside here in air. Okay. What is it? Just mount it here first. Yeah. Okay. Good. Excellent. It's better to have them prepared. It's a little bit better than when they are not unprepared. Like that. And I'm looking to be parallel with the other one, and it is kind of. Like this. And voila! Ta-da-da-da. Very beautiful. Very nice. It's not absolutely necessary to prepare them, but I believe it is a good exercise. A good one. Excellent. And this one. This is ensuring me it is catching very, very well when I'm preparing them, that I will not have surprises, especially on this long or high components that I'm having here. No? Okay. Not a... Right. This is fun. This part of mounting the components is very fun. It's very nice when you feel you are building something, you know. And not many left. The resistors here and here, and then the LEDs, and that's it. I'll have to bend their legs like this. Also preparing them as well. Well, excellent. And this other one. So I'm making the resistor legs like this, and here is the body of the resistor, and here is like this. You see, I'm bending the legs to actually to stay on the pads. This is called forming the legs. You know, I'm forming them a little bit. A bit like this. Okay. Okay. That's okay. Okay. Excellentos. And now this leads, but I don't know which is positive and which is negative. And I can guess, but I don't want to guess. So I will do it like this. I'll try them. Like this, and with this resistor here. No. Like this there. Yep, I can see it lighting up. So this leg is like this. Like this. Between that and that. Yeah, it's on the margins, on the limits. Yep, good enough. Like this. And let me check it again to be sure. So negative, positive, good. It's very weak. It's very, very weak, but probably I will have to change the resistor. But in time. And this one's there. Check it. So another here. Yep. So this is negative here. Positive here. Good enough. Okay. And voila, that's it. Let me test it again. You sure? Yep, good. Okay. This is it. This is how I mounted the components. Hope you like it. I'm not sure what is to like at this stage. And next, I will have to make the wires. But I will not film it because that is very boring. All right. Here is the stage where I've added only the power lines, the power wires, exactly as you can see here. The red ones and the blue ones. Blue ones for the negative, red ones for the positive, and is exactly as in my diagram there. And of course here is a little bit weird configuration here on the bottom. It's not exactly like there, but it is following the same logic. So this 0.8 is actually linked here to this pad, and this 0.4 is linked here to this pad. So it's positive there and negative here, exactly as it should be. And next I have to link, I also linked this wires from this DIP 8 chip to this potentiometers. But next, all that remains to be added is the links from this this 6 links, and and also the output there and there to be dragged here and here, but somewhere underneath everything. So until now, only the power line wires are added. What you can see here. I hope you like it. All right, that's it for this part. All right, so I finished it. I linked everything. I even made a test, and everything is working as I imagined and as I planned. Very straightforward and very easy to make. This is the interior of the chip of this operation opamp, dual opamp. It says there. It's having one opamp here and another here, A and B. I don't have anything mounted here. And now I will make the tests and show you how all this is working. By the way, this is 5 volts there connected. I have to size this of the op-amps, and I will test the little one now because it's easy to remove, and this one is a little bit harder to remove. I have to be a bit more careful. Like I said, you see this is separated, this is another piece separated, so they are not linked between them. I just cut something longer and I use it. You can even see the spring here. So that's why I'm saying it's a bit harder to remove from here, but it's okay. I mean, if I'm using 2 hands, I can take it out relatively easily. I have to insert it correctly like this, and when I will leave it like this, nothing will happen like that. But when I'm pressing it without moving anything, so this op-amp is this side here, and this op-amp, which is A, is this side here, the control and the LED. I changed the resistors with 270 ohms, very small value. Now I can lit up a little better the green LEDs with this value, and of course I randomly choose it. But so when I'm pressing it like that, hopefully you can see everything I'm doing. So if I'm rotating from here, now I'm controlling this op-amp here. If I'm doing this and this, is working. Okay, so this is for negative input. Now for the positive input, if I'm doing this and this, is lighting up and getting on and off this LED. And this is telling me this gate is functioning correctly. It's not having any issues, any problems. So this is what all this testing circuit is doing. It's telling me the gates, these op-amps are healthy inside the chip. So I don't have any kind of weird, strange errors. And now this side, when I'm rotating this, that is shutting off. And when I'm rotating this, other one is shutting off as well. And that's it. This is all the tests. It's telling me this op-amp is functioning correctly as well. Okay, so now I will take it out very easily. And I will insert this other one, which is a DIP 8 version. And I don't have to press it there. So the same thing, if I'm rotating from here, it should get on and off, this LED. When I'm rotating from this, you see, on and off. And this is telling me this gate of the chip is functioning normally. So it's okay, it's fine, it's in good shape. And when I'm switching from here, this is good. When I'm switching from here, this is good. So this gate or this op-amp here is perfectly healthy, is good, is fine. So I have two sizes of op-amp, one or another, not two in the same time. So I will have to take it out to measure this little one, and I have to take out the little one to measure this bigger one. So that's this is the deal, and pretty much that's it. This is my tester, and it is looking a little bit complicated because of these wires here. It is having some back wires from here, and here, so 4 wires. Also this wire from here to here, and from there to there. So the output, this output from there and there to this pad, and this white wires are also the output for this little one here. And but I have 6 wires underneath under the cardboard. You cannot see it because I put this is a third cardboard here. So I have this cardboard. I have another cardboard. This one that you can barely see it here. That is protecting all the pads from this cardboard on the other side. So it's insulating those pads from touching. And then I drag the wires. These wires that I mentioned it. Over this secondary cardboard, and then this is the third cardboard that insulation cardboard that I covered those and protecting those wires that are flimsy, that are very long, and they are bending, and you can catch them. And this is the whole construction of the thing, and it's quite robust. Of course, if you force it too much, it will bend, but by itself, it is resistant to vibration, to handling, roughly handling. It's quite okay. It's quite okay, and I'm very pleased with it so far. And yeah, it's pretty cute. It's a cute subject. It's a nice. It's good to have a tester because I do have some scrapped op-amps, and I want to check them if they are fine, if they are good, the scrapped one. But I'm also having some testing op-amps that I'm testing them a bit forcefully. And I know I'm stupid sometimes, and most probably I'm applying some voltages that this chip should not see. And that's why it's very good to have a tester like this to see if I fucked it up, if something is fucked up. Because I did get some very strange results in my earlier tests that I did before, and I didn't know why. And I said I must make a tester. I must have a tester to actually see if the chip is good or not. Because I was blaming the chip, and the chip was good actually, but the circuit was bad. But having a quick tester like test board like this, telling you if it's good or not, it will put you back on the track very quickly. And this is the purpose of this project that I made here. I hope you like it. Leave a like. And don't be a motherfucker and leave a dislike. I have one single viewer that is leaving me one dislike, and I don't like it. And do write, type a message what you don't like if you don't like something, but don't leave dislikes there because it's fucked up, you know. All right, thank you very much. See you later on the next project, hopefully. All right, so this is the circuit. I promised I will show the actual circuit here. In my circuit that I used, I put from here, this LED here, that was going to ground without this one. So this one is not in my circuit, neither this resistor. So this is my arrangement that I'm having for, and this is for only for one single op-amp, the circuit, but it's very easily, you can very easily extrapolate, and you can make it a double for the other op-amp. So basically, if I'm moving this potentiometer, this spot 1, I'm moving it left and right here, the LED will turn on and off, exactly as in reality. And if I'm changing pot 2, also the same thing should be. So this is telling me that positive and negative input of the op-amp and also the output are completely are working perfectly fine. This is what is telling me. This simple test that I'm doing here, very simple, is telling me this is operational. This is working in good condition. It's not having any kind of issues. So that's it. This is the purpose of this circuit. Probably I should show you the 3D version as well. And here it is. This is a screenshot that you've seen it on my phone. That I took it from here. From my computer and upload it into my phone. And here's the 3D Max 7, very quickly to load up, extremely quickly. As you can see, here is saying is version 2, but here I have a version 1, and the difference is that these two potentiometers are not in line with these ones. So that's the difference. So in version 2, I lined up the potentiometers, and these are some. I was playing around, but I really didn't like it. I can show you actually how it's looking. I was thinking to make this kind of modules, but nah. I didn't like it because I had to put my finger over this chip, very small chip, to hold it in place. It's not the case for this bigger one, but for this little one it is the case. So this was the plan, this was the sketch. Let me show you a turnaround. And yeah, in the final circuit, because I used a very weak and very old LEDs. I used, instead of 1 kilo like I originally planned here, I used 270, I believe, ohms. And that's it. It's because of the LED luminosity. I used a smaller resistor value to bring up more luminosity in those very weak, very old, very shitty LEDs that I scrapped from somewhere. And that's it. I hope you like it. This is it. Bye bye. And leave a like. Bye bye. For now, from your favorite artist electronist, Mr. Q12. Alright, bye bye.